Now, given that A prime and C prime are not mutually exclusive, just means that they are no longer exhaustive like that lah. Okay, but they're still mutually exclusive in the sense A and C are still mutually exclusive. So what you do is you could actually technically draw these three circles here like that. Okay, so A and C is like just what do you call it, apart lah from each other. Okay, then now you're given that PA is 2/5. I can just put in decimal, this 0.4, right? Then you get PB intersect C as 1/5, which is actually just 0.2. So PB intersect C is here, this is 0.2. And then PA prime intersect, so outside is 0.1. Correct? So it just means PA union B union C is actually goes to 0.9. Actually, they are asking for the range of A intersect B. This is here. Those contain expression. So here, for example, if you're looking at this, right, this over here is actually contain. Oh, you can't see on the screen. So let me use this over here. As long as it's 90, your 0.9 will just contain inside here. Okay, so it doesn't really it's not really that important. So what we need now is actually finding, because since A and B are independent events, so we could actually technically there are many ways to label it, but I think the easiest way to label is put this as X and put this as Y. Okay, let basically let P B intersect A prime intersect C prime by, and P B prime intersect C bx. Okay, so that's one. So that's one. Why? Because I know that the whole A here is actually just, the whole A is 0.4 lah. Okay, the whole A is 0.4. So I know that actually I could find the middle portion here with using the formula lah. You can actually use the formula, this middle portion here. Okay, so it's 0.4. You know that you can find in terms of A actually. So okay, first we take the most obvious one. Okay, let me take a not so jarring color. This is 0.4 here. So what I'm going to do is actually, I know that 0.4 plus y plus 0.2 plus c is equals to 0.9. That is a given. Must contain. So this, the whole thing inside here, 0.4 plus this whole thing here must be 0.9. So in other words, you have y plus x equals to 0.9 minus 0.6. I guess that will amount to 0.3. This 0.3 here. First part. Now the second part is this. Because we need this, so we need to find the inequalities of this yellow region here. Okay, this region. So we need to find this inequality in terms of x and y. Then we can crack the code. Okay. So first thing, you know that PA intersect B is what you want to find. It's actually PA times PB. Okay. So we just gonna try and solve it. So here would be PA intersect B will just be, A is what? A is 0.4. PB is just PB is just PA intersect B plus y plus 0.2. That is PA intersect B. Oh, there you go. I got my answer already. So here, we 0.4 PA intersect B plus 0.4 y plus 0.2 times 0.4, 0.008. Okay, then A intersect B will just be 0.6. 4 marks, this one. Because in inequalities, right, we managed to find PB in terms of Y. Now it's much easier. PA intersect B depends on Y. Okay, so when is PA intersect B maximum? When Y is what? How much can Y be? From this first one. How much? Maximum of Y? Is what? Y plus 3 equals to 0.3. No, you must understand that this 0.3, right, can distribute among x and y. So you can just free for all. This you can distribute it. So max of y is how much? It's just 0.3. Mean of y is just 0. So now you tell me PA intersect B maximum will be 2/3 times 0.3 plus 15 over 2. Minimum of PA intersect B will just be 2/3 0 plus 15 over 2 lah. So key this in. So maximum will be, minimum will be 1/3 lah. Okay?